Hi everybody. So today we'll be starting the demo class for our first class. Just a minute. So today is our first class for the demo class for the Teach for Free, where I will be taking you through the basics of C programming. So I am using Google Hangout for this process, as you can see, and this is a demo class. And in this, what I will be doing is I will be sharing my desktop, and so the mode which we will be teaching, I will be teaching you guys from now on. Whoever will be joining this program is via Google Hangout, so you need not to install any extra software or anything for that purpose to attend the classes. You just have to have a Gmail account, and I will send you an invite. And once you are invited, you can join the Hangout call, like here we have joined. So once you have joined the call, then I will be sharing my desktop, and I have a whiteboard and also have a Wacom notebook actually, where we can use to read and write, and you can also interrupt and ask questions, and this can be very interactive. But since this is a demo class, we will not be having the possibility of asking questions, because I am the one only speaking here. So from next classes onwards, when you join, we can have it very interactive. So all said, in summary, what you need is just the interest to learn for free, and absolutely 100% free from my side. And I am doing this just to gain knowledge, and also to take quality education to people who cannot afford, or to people who are at a location where they cannot get proper quality education. I have started this for computer science, and once it is a hit or it goes on well, we'll expand it to many other ways. So what you need is to only have a laptop or a mobile phone or a tablet with an internet connection and a Gmail account. That's it. You do not need to have anything else. I'll send you the invite. You can join in the Google Hangout, and our class starts. So now I'll share my desktop, and we'll go to our first session. So here I am sharing my screen. So I have shared my screen, and hopefully it is visible to you now. So I have a presentation here, which I'll be sharing with you. So this presentation here is the guideline using which we will be teaching you, and not necessarily this is the only thing that we will be using. We will also be using to show you a Xiteboard. A Xiteboard is a whiteboard which we can use to draw interactive things, and using which things I can teach you things like in a blackboard. So the Xiteboard will be mapped to my Wacom notepad. So if you can see a Wacom notepad, so this is my Wacom notepad, and I have to map the pen to the area, and I think it is well mapped already, so I do not need to do anything, and that's it, done. So here is my first class. So this is my first class. First class for teaching for free. As you can see, I can use this as a whiteboard to do whatever I want, like a dust like you use in a classroom. I can clear it out properly, just like a whiteboard. So this one we will be using too often. So so before I start this, let's move ahead to our presentation, and we will start our class from there. Okay. So this is the first demo class, and this class involves the life cycle of your C program. The audience here, I assume, is well acquainted with writing at least Hello World C program. I am not expecting any in-depth knowledge of C programming. Just an Hello World C program they should be able to write, and they should be able to know that at least the basic syntaxes of writing programs. So because we will not be detailing out here the syntaxes and structure of the program, that is a theory thing, and you can get it from any book or internet you want to. So we will be covering here topics which are not normally covered in the classroom or in a book. So these are the knowledges that has been explored and gathered from my 8.5 years experience in the IT industry, and especially working very close to the system, operating system, hardware, peripheral devices. I have gathered this knowledge, and I want to share this knowledge with you guys, and reduce the gap between engineering and industry. So take it as an opportunity like that. So the topics that I will be covering here is your first C program. That will not be as simple as a hello world. Then what happens in the background after you write the program? What happens? We'll go to that. That is a funny thing. We'll see the journey from your program to process. If you know, it ultimately becomes a process. That also will show you how it becomes. Where is your process? You are running your program in your laptop, your desktop, or your computer server. So where is that process residing in your machine, physical machine? Then walking through your process memory. That is the most important thing. If you don't understand the memory layout of your process, then you are not a good programmer, and you will be making a lot of mistakes. And then the journey from your code to the CPU. So as you know, ultimately everything runs in the CPU for a program, for a computer, be it a very complex program like simulator, space simulator program, or a very small hello world C program. Everything runs on a CPU. So how your C program runs on a CPU, that one will go through. So here is our first C program. As you can see, let me expand it, and it will be more clearer. Okay, so this is our first C program. Okay, so I'll not go through line by line here. So I will be distributing this. Every session is recorded, and plus the documents or the PPTs and the whatever documents related to this class will be shared to you. So there is no need to be worrying about it. So as you can see, this is my first C program, and I will not go through line by line, and you can see in a gist that this is fairly a little complex C program as for what you have started learning. It is not as complex as a project, a full-fledged project, and it is not as simple as a hello world program also. So this is a fairly simple but complex program, and we have done just some variable declarations and some prints. That's it. And then I have two screenshots. One screenshot showing the file system where the main.c, that is our C file program, and then some other files with various extensions. I will go through each extensions, what are those, and we have a output of this program. So the output doesn't matter, so we can have a lot of tricky programming and have a lot of tricky output which can confuse you. But as you all might have already faced when you go for campus recruitments or for any C classes or in Kanetkar book or wherever, you see a lot of magic, you see a lot of tricks, tips for finding out the output of this program, that program, giving you a lot of confusing statements in between each other, static variables, global variables, automatic variables, and then lot of semicolons, lot of parentheses, and lot of pre-post operators, and ultimately you get confused and you have to write the output. So that is, I'll tell you, the most bogus way of testing anybody's knowledge in C, and that is really bad. But that is the way our interview processes are, and even today, when I am 8.5 years experienced, I also have to face such questions in interview. But the basic fundamental thing here is, if we understand how our program is laid out in the memory, in the computer, how it is when we write this text thing, like has included stdio.h char g is equal to 10, how this is converted into the binary exactly in a computer, then these things becomes a cakewalk. Since we don't understand those things and we just memorize, okay, if this is this, then this is the output, if this is there, then that is the output, and if somebody tweaks a little bit, then we are confused and we don't have an answer and we feel it is so difficult. So it's not. So for example, I can tell you, common cold may look very complex to a layman, and he may be baffled by the complexity, why X person gets common cold and Y person doesn't get common cold, and he may be asking a lot of questions and he may be thinking this is really dangerous. But a doctor or a person who works very closely with these viruses in the laboratory, they won't be, because they exactly know the functionality of the viruses, how they attack, how they get into the body, where they attach into the body, what are the possibilities. So they know everything. So for them it is a very easy thing. Okay, this person will get, that person won't get. So they can just tell the answer like that. So here also the same thing. So what we think C programming is common cold and it's very complex. We don't understand. This may work, that may not work. You can tell it works in my machine, it doesn't work in his machine. Those things we will tell. You can tell it was working yesterday, it's not working today. So something happened. So those gray areas, why this type of statements we make, this is not a probability statistics thing that tomorrow it works and today doesn't work. Everything has a reason for computers. So if you understand the basics correctly, then our reasoning will be perfect and we'll know what is happening. Anyways, let's move ahead and I will come back to this slide in a short while. So what happens in the background? So when you write your program in the file, I don't know, most of you would be using an IDE or not, but for simplicity's sake, let's think that you are using some kind of editor to write your program. By editor I mean a screen where there will be a cursor and whatever you type in the keyboard is exactly printed there. So in that sense I can think Notepad as an editor also, correct? So in a Notepad, if I give you a Notepad with a computer that has only Notepad application and I ask you to write a C program, you can write it. And in that sense your note copy, physical note copy, is also an editor where you can write it using your pen. So it doesn't make a much difference, Notepad or note copy, same thing. So for you it is a place where you can write your program. Once you have written that program, that is as good as writing a love letter. Okay, it is just something written which makes sense only to a person who understands C programming. If you give it to your girlfriend, it doesn't make any sense because she does not understand that language. So as long as it is written in that text, it is just a text. That's it. It has no power, it has no soul, it has no spirit. It is like a dead body. Okay. So now we have to convert this text into something that can be understood by the computer. Okay. So now question is, why couldn't we just write it in plain English or our native language? Why so much syntax and all? Yeah, this is a valid question, and you can give it a try to someday develop a programming language which is as simple as English language. But you have to understand the complexity that a Spanish person may write the English in a different way and an Indian person can write it in a different way. So you have to have compilers which can compile any type of English. So that's why to standardize they have made something which is like English but has a set of rules, so that everybody, a person from Spain or a person from India or a person from Kenya, everybody when they write the C program they write it that way. So that is the reason that it is little weird but English like. Anyways, so when you have written your C program, that is this, since you know, you have been taught in your class, you know the syntaxes and you have written it, what you do is compile it. Now in your engineering college and all, I don't know, you may be using a lot of compilers, or you might not also have an idea that you have a compiler. You just think magically it compiles. What is a compiler? You might also not have never tried to think. No offense, this is how also I used to think. So some of you might be smart enough to think and understand this thing, but this is a demo class, so I don't know the audience. So you just your lab practitioner or your teacher says just compile it, and you tell how, and they say press F9 or in some ID F6 or in some ID Alt K or Alt L something, and you just do it and something happens, and luckily if you have written it perfectly as per the book from where you copied it, it just compiles, and then you said yes, it compiles. Then the lab practitioner asked you to run it, and you just run it, and that is also how, by pressing a switch F5, F6 or Ctrl K something, and it runs. So and you see the output, great. So you have done your C programming. But what was happening behind, we never tried to know. We are happy we completed our C program, we are master of C programming, and we went home. But we never tried to understand what happened when I pressed F9 or F7 or F6. Yeah, so here we will come to know what happens. If I start talking about every little detail, it will take a lot of time, and this demo class will convert into an entire computer class. So I will leave some gray areas that we will cover in topics later on. So by compiling is just a vague term. Actually it happens in 4 processes, that is pre-processing, compilation, assembly and linking. And GCC is a compiler, G++ is also a compiler, Borland is a compiler, Turbo is a compiler, ANSI is a compiler, Microsoft Visual Studio is a compiler. So there are many compilers which understand the syntax of C language and are targeted for a particular machine type or a operating system type, maybe 64-bit, 32-bit, Linux, Windows, Mac has Objective-C. So compilers are many, but the main objective is they all understand the same syntax. Now I have used GCC compiler. Why? Because I like it. No special reason. So when I compile this program, I can give special flags to generate intermediate files. Means I can directly compile and get the executable, the final thing. But to understand what happens in between, I have used certain flags in the GCC to create intermediate files. Okay, so to know what happens. So as you can see, there are 4 intermediate files. .i, .s, .o and .exe. Okay. So what is a .i file? Macro substitution, comments are stripped of, expansion of the included files. So these are alien terms, maybe, may not be, but for people who don't know, don't sweat it out. We'll discuss about all of these things in our classes. Just to understand, I'll show you something. So we had main.c. If you remember, main.c was this one. This one was main.c. So here we had include stdio.h. This is an inclusion. We did not have any macro, we did not have any comments. Okay. And if you see, main.c has been converted to main.i. And this one is just a snapshot of the original file. If you see here, main.i's size is 56k, whereas main.c's size is 1k. So all this text that you wrote only comprises 1k size, 1 kilobyte, whereas an second intermediate file just after .c.i was generated, and its size is 56 kb. So it is 56 times the size of the original text file. What has been added that the size becomes so large? It is stdio.h. So whatever we included, that entire file got inserted into this file. So stdio.h, we can assume, is 55 kb and this file is 1 kb, so total 56 kb. If we had any macros or we had any comments would have been stripped off, size would have been reduced a little bit, macros would have been expanded, size would have increased a little bit. Ultimately, main.i is always a larger size file. So if you write hello world also, that will be around 55 kb because it includes stdio.h. Any inclusion will be expanded here. So that's why here we have done it. And you see, our function is as it is here, from here to here, our program. And above that, a lot of things has been included. Lot of things. These are all things from stdio.h. And also remember, stdio.h in turn also includes a lot of includes, like time.h, like types.h. So all those recursively gets expanded and included. So your .i file becomes an independent file containing the definitions and declarations of everything that is needed for that program to run, which was kept abstracted and hidden from you when you wrote main.c. In main.c you wrote a very small program, you just included stdio.h, but that got expanded into main.i. Now from main.i becomes main.s. What is it doing here? Adding assembly instructions. So assembly instructions, if you see, I don't know the audience here, so I don't know you have had any experience with assembly or anything like that, but assembly is the language of the processor. So suppose your laptop has Intel i3 processor. So Intel has a sheet that it publishes and it tells that its processor understands these instructions. For example, if we are doing char I is equal to 100, so that means we want to store 100 in a variable called il, and it has a corresponding set of instructions in the Intel i3 processor. So this .s file is completely dependent on the type of machine that you are running. So suppose your machine is AMD processor, then this file instructions will be different. This command like push L, move B, so this all will be different. Maybe in AMD it is only MOV and in Intel it is MOVL. So So this s.s file is an assembly file. So what we can see from here is main.c was very English like. Now main.i is still English like but more cluttered and confusing. Now main.i to main.s is still English like but more confusing. So we are slowly going towards machine and moving away from human readable. So this is the second step, that is the assembly language. So all our instructions, including the include files plus whatever functions we have written and whatever lines of codes we have written, has been converted to the corresponding target processor's machine language or the assembly language. Sorry, not machine language, it's assembly language. So now question is, why cannot we write directly the .s file? Yes, you can very well write it. If you have the patience and time to write all this in your code and remember the entire sheet provided by Intel for its processor, then you can very well write it. You don't need the C programming language at all. You can entirely bypass the compiler, right? So that is not possible for a human to do. So yeah, there are some areas where we need assembly. I'll talk about it later, but not now. Okay, so once .s is done, what happens? From .s you do .o, adding machine understandable instructions ELF. ELF stands for executable and linkable format. Okay, so from .s we create the .obj or the .o file. Obj is for Windows and O is for Linux. So object file, this is called object file. As you can see, this is I opened that .obj file in a notepad and you can see it is completely not readable. Okay, you can still see some data things written there, but overall doesn't make any sense. Okay, so this is where we got entered into machine readable language, from assembly to machine. So as a layman I can say you, consider this a bit of zeros and ones, where current is there or current is not there. So that's why you call object files as binary files. So in industry when you work, many times people will say you that where is the binary? Where is the binary? So this is a binary file, because ultimately this is machine readable, and what machine understands? Only 0 and 1, whether current is there or not there. And when these zeros and ones will be fed to the gates, logic gates, like you might have read in your digital electronics, XOR gate, NOR gate, NAND gate, the current flows in certain way that it starts working as our functions, like char I gets stored into the memory. All these things happen, magic happens. So this is the object file, and there are particular formats of machine readable, and this is ELF is the latest format that is understandable by certain type of processors. So this is ELF stands for executable linkable format. So this is an ELF format file. Okay, from this obj then we do the exe. Okay, so what this exe does here is, until this stage the compiler does not know the definition of the function like printf, all this. So yeah, this is a very important thing I'll tell you. So in .i you expanded the .h, include .h, stdio.h. We have directly used a function called printf, if you notice. And we somehow imagined that it will print in the screen because our teacher said so. But we never questioned why printf will print in the screen. Why? From where it will get the instructions to print in the screen. Okay, now teacher will say it is in stdio.h. Fine. But stdio.h is a header file, and if you open stdio.h and read it, you only see the declaration of the function printf. You don't see any body or the function definition or the implementation of printf, how it prints in the screen. You don't see. You just see a declaration. Now in .i file, that means only the declaration is there. That means this .i file got converted into obj, and here also only the declaration is there. So how it knows what to do in printf? That happens during conversion to .exe. So until this stage, the function does not know the definition of the functions like printf, and these function definitions are present in standard C runtime libraries, which are called the CLR libraries, C runtime libraries, which are coming as a part of the package of your compiler. So when you get a compiler, you get these libraries. What are libraries? For now, understand, libraries are a box inside which functions like printf's definitions are embedded. That's it. So these boxes are coming as a part of the parcel with the compiler. So when your .obj is converted to .exe, your linker, here the linker comes into play. Okay, this is linking. Your linker, what it does, it sees the presence of any unknown function whose definition is not yet known, and here one function like this is printf, and then it searches whether this printf function is a user defined function. Like we have a user defined function here, function 1. I have defined this function. So now in main it sees function 1, and it's okay, function 1, I got it. Where is the definition? Okay, here is the definition. So I don't need to find anywhere, I got it. But then it encounters printf. Oh, printf, where is the definition? No, it is not here. Then it searches in the standard C runtime library, which is linked with your program, okay, by default. And then it finds the function's definition inside that library. Great. Now it picks that function's address from that library, from that box, and places it inside your obj file, so that your obj file in itself gets converted into a standalone unit which can run in any machine. Now you got your exe. So this exe is a larger size file, that's why. See, if you see here, your exe is around 48 KB. Yeah, now you see why 56 is I and exe is 48, because I contain text and exe contains binary. So size required to store 0 and 1 is very less than the size required to store ABCD, that we all know. So that's why for storing A we need 8 bytes. For storing 0 and 1 we need only 1 bit. Okay, so there is the size reduction. But still 48 bytes, 48 KB for zeros and ones. Why so much big? Because .exe in itself is now a standalone unit, a independent unit which can run in any machine even when your compiler is not present. So you created a program, you compiled it using your compiler in your machine, you created the .exe, you take that .exe in pen drive, run it in a same target machine. Remember, the target machine should be same, because the assembly file, the assembly instructions should match. You cannot compile a program that is 32-bit Intel compiler platform and run it in a 64-bit AMD processor. That will not work. For that, cross compilers are there. We'll talk about it later. But here, you compiled it in a 64-bit Intel processor machine. Take that into any 64-bit Intel processor machine. You can straight away run it. Your .exe is a standalone unit. Okay. So here the linking is over. So now you understand the text that you wrote in main.c, how it got converted into a standalone unit containing all the binary information of zeros and ones that is ready to be run in a system of the same platform and same processor. Okay. So here is our introduction about the demo class, about what happens in the background. The journey from your program to process in Linux. This is a very interesting topic that I will be talking about, and you will be knowing how your that exe file that you generated ultimately gets life, and like a dead body comes into life and starts running in an environment. We'll come to know about that, but for that we can go to our regular classroom programs, and this is just a demo class, and I just made this class to give you a feel that how differently we can see at a simple C program that we have been writing and reading for so long and never thought about what is going in the background. Many of you might already be knowing it. That is really great out of your enthusiasm. Many of you are not. But believe me, there are a lot of nitty-gritties and small things that you need to know if you have to master how a computer works. So being a computer science engineer, this is our duty and responsibility to completely understand how our program works in the computer. That is very, very, very important, because if you are writing a program in a embedded platform like a small mobile phone, nowadays mobile phones are coming with 2 GB RAM, but imagine a mobile phone which is coming at only say some MB of RAM, and you have to write a program there which works like an operating system like Java. It is a programming language, but itself also an operating system. So imagine the depth of knowledge you should be having in understanding how that program is laid out in that MB of memory, and how efficiently you can use that memory to execute your program and ultimately achieve that thing. Not only this, you imagine about the spaceships, the rockets that go into space, and they are all embedded programming. So you cannot just keep on making new variables and clearing out the space. Even taking a small flash memory into the space costs billions of dollars. So that's why you have to be very careful in understanding how your program runs in the memory and the computer. It is not just about writing the logic and getting the output. So with this I stop my first classroom, and if you like it, you can just drop me a mail or contact me in any way in the pamphlets as shown. So here is the things that this is all about. So this is our free education for all. So this is my humble start, and I want to, the objective is to bring online computer education to each and everyone, irrespective of who you are, where are you, and it's 100% free and 100% committed to educate you until and unless you are satisfied. So this is the target of this classroom based coaching, and you just have to have a Gmail account. That's it. So if you like it, drop me a mail or call me, WhatsApp me, anything you can do, and we will just connect, plan classrooms, and then we can go ahead and start teaching. So here are the details that I have. I'll also be publishing this, so no worries, you can get it. So, and if you want to join me and teach others, you can do it. I'll tell you what you need. So this is it. So I'm signing off with this. Thank you.